Hi, it's me again. I just want to touch base with you regarding experiment number 3. I received an email this afternoon regarding the calculation of, or rather standardization of sodium hydroxide. I will share my screen and walk you through on how to standardize sodium hydroxide before using the standardized sodium hydroxide in the titration of the unknown sample. So let me just share my screen here and pull the data sheet. This is the data sheet of which I know everybody did the phase acid ratio and calculate the R value with the three consecutive reading within 3 parts per thousand or less in agreement, of which, if you look at this value here, all right, this is the R value which you had to determine, okay, and if you look at how the equation has been derived, it's the ratio of the what milliliters of NaOH to milliliters of HCl. We can rearrange this by to give the ml of NaOH, all right, NaOH. If we multiply the R value, which is the average of the three, all right, you have the R value for the average times the ml of HCl. This ml of HCl is the milliliters used for pack titration for each trial. Remember, you had 3 or 4 LMR flasks with different masses of KHP. Technically, you are supposed to over titrate each trial and then pack titrate with HCl. So let's roll down to, I'm just going down to the data sheet, which once you determine the R value, you are supposed now to go to what? To the titration of your standard titration of your standard, okay, by having what? A sample of 0.700 to 0.800 gram of sample in 4. So you are supposed to what? Over titrate and then you pack titrate. Each flask, depending on which indicator you are using, you know which color you are looking for. If it was phenolphthalein or thermal blue, you knew the characteristic, or you are supposed to pay attention to characteristic color you expect when your sample was over titrated. Let's see, for example, for trial 1, all right? Let's say trial 1 here, all right? I'm going to use trial 1 here, and in trial 1, all right, in trial 1, you are supposed to have period A. Let me just call this period A with NaOH. This is as NaOH, which we don't know what. We don't know the concentration. We are standardizing this. And then period B on this side, you are supposed to have what? You are supposed to have HCl, all right? This is HCl, okay? It's hard to draw using my mouse. And this is NaOH, all right? This is NaOH. Remember, we are using only one flask for what? We are using one flask for trial 1. This is the 500 ml flask with your sample. And here you had what? You have 0 point what? 0 point, this is 0.1 molar what? Molar HCl, or just put it HCl. You know, you can just call it HCl even though we may not need the molarity for that, but we just know that it is HCl. So in first trial, all right, if your initial volume, all right, if your initial volume was 0.00 ml, that is where the meniscus was, and then you titrate this sample, okay? You titrate this sample. If it is, if you had phenolphthalein, all right, if you have phenolphthalein in this sample right here, assuming you over titrate, until you see pink or intense pink color, that is signifies that you went beyond the equivalent point, the point where the number of moles of KHP here, remember you had KHP here, with known crowns. From this known mass, you can find the number of moles. But that is not what we are looking for here at the moment. We over titrate, or you are supposed to over titrate this sample. And let's say you over titrate and then you have 25. I'm just picking up this value here. This is 25.0, 0.000 ml. And the color is intense pink. We know it is pure. We or you are supposed now to take this flask and starting from 00 here. Let's say you are starting from 00 for HCl. All right. You want to pack titrate. You want to pack titrate the. All right. You want to pack titrate the over titrated sample of KHP. But before you do that, you need to record what? You need to record the initial and the final. So my, all right, apparent, all right, if I'm using period A, I'll indicate A here. And initial is what? Final is 25 point what? 25 point 0 ml, and my initial is what? My initial is 0.000 ml, and of course you can get the apparent from here. You can get the apparent what? The apparent volume. This is the total volume of. This is the total volume of. Call this total what? Total. No, this is for acid phase. I meant to use, this is for phase. This is for phase. All right, I need to clear this. This is for phase acid ratio. We don't need this. This is what I meant to say. We will have to use the lower one here to make sense. This one was for, yeah, this is what I meant to use, standardization. So with that, let me go back to my cartoon. All right, this is grade A, this is grade P, and we have what? We have our HCl here. All right, this is HCl. We don't know the concentration. Okay, and this is grade P. We just stop up there, and what? This is the grade A. This is A with NaOH, which we need to standardize. All right, we need to standardize this. You know the mass of KHP you had in sample 1, sample 2, sample 3, sample 4. You know you have the mass of that. So we're not going to take into account that. But here is what you had to pay attention now, that your sample, all right, was over titrated. And I picked before initial volume to be 0.000 ml. This is the initial volume. And the final volume, I hypothetically pick it to be 25, 21, 25, point 0, 0. This is over titrated sample of KHP. All right. You are to titrate this sample of KHP, known mass. Remember, it's known mass of KHP for trial one. This is the 500 what? 500 ml LML flask. This is the 500 ml LML flask. And of course, you have the indicator and 75 to 100 deionized water. It is over titrated and over titrated total volume here for period A. So this is period A for NaOH. All right, this is period A for NaOH right here. What's wrong with my annotation here? A and ACL, this is D right here. I'm just gonna have D right there. So initial here is what? Initial here is, or final here is 25.000 ml. And here is 0.00 ml. Of course, apparent will be what? 25 ml. This is ml, and this is ml. Now, understand that this is over titrated. That means we have extra NaOH here, and we have to account for the ml of NaOH consumed by ml of KHP. So how you account for that is, if we have excess, this is over titrated. This is the total volume here. To get the ml consumed by KHP of NaOH, we need to account for ml consumed by part titration. You will now move this flask, or you are supposed to move the flask into under the period P with HCl, and you do what? You part titrate to colorless. It is acidic. If you are using, of course, phenolphthalein. So if I am using, or if you are to part titrate this, and I'm just picking up some numbers here, 0.000, and then maybe you use a small amount. Sometimes you may even, let's say 1 ml, or maybe 1 ml or 0.5 ml, whichever volume you use. You have to account for how many ml of what? How many ml of ACR did you use to part titrate your over titrated sample of what? Sample of KHP. Remember, KHP is an acid. Remember, HCl is an acid. So any amount of in all the ml of NaOH in this over titrated sample will be consumed by two types of acid. One is KHP, which is an acid, and the other acid is HCl. So here I'll just say my final here is what? My final is 1.00. This is for trial one, and initially 0.0 at 0.00, and this is the apparent 1 ml. So I know the ml, all right? This 1 ml consume the NaOH, the over titrated, the extra NaOH in the sample. Majority of NaOH sample which went into the flask were consumed by KHP, and the leftover actually were consumed by the part titration. So that when we get to calculation, hope you have understood up to this point, this was just 4 grams. I'm just zeroing in here, all right? And how we will reconcile with the calculation. Remember, this is over titrated sample, so that when I go back to, okay, I will clear this, all right? Remember, there is 1 ml here, and there is 25 ml, which is the total here. Let me clear this, and I will now go to the calculation. I'll now go to the calculation, and I think it's down here. I believe it's coming down here. This is for the unknown. This is the calculation part now. From the pace acid ratio, you know the R value for the tree trout. We need now to standardize to know the exact, all right, to know exact molarity of NaOH, which is molarity of NaOH, all right. That is molarity of NaOH is given by what? Is given by number of moles of NaOH, all right, number of moles of NaOH over what? Over volume in liters of NaOH. Now, since, all right, since the number of moles of NaOH is the same as the number of moles of KHP, mole ratio is 1 to 1. All you need, or all we need to know is the volume of NaOH. Remember, mole ratio between KHP and NaOH is 1 to 1. So if you know the mass of, KHP in trial 1, it's the same as the number of moles of what? NaOH. And now we need to find the volume of NaOH in trial 1, change to liters, so that when we plug in the equation, we will know the molarity of NaOH. So in standardization, we need to know the ml of NaOH consumed by the KHP, or with the total, which is now the over titrated here, is same as the number of, or ml of. So this is the 25 ml, which went into the plus number 1, which is 25 in my example. The ml consumed by KHP, we need to rearrange. I know I had what? I had 25 here for over titrated. All right, in that example, this is over titrated ml. And then this is the question mark we are looking for. This is the one I used to pack titrate to colorless. Remember, when you added HCl on the second red, it consumed the extra ml of NaOH. So this was 1.0. Using that example, remember it was 1 ml. It was 0 to 1, so it's the same as 1 ml. So if I rearrange ml of, all right, ml of NaOH consumed by HCl is the same as the R value. All right. First of all, before when we get there, this is what I want to say. ml of NaOH consumed, this part right here, is obtained from R value, which is the average of the 3, times this value, 1. This was 1.0. This is the one we use in pack titration. ml consumed by HCl is the same as ml consumed by HCl is the same as R times ml over HCl. We know the R value from the previous calculation. So from the pack titration, we can get the number of moles from the mass of KHP. So here, rearranging the equation, ml of consumed by KSP is given by ml minus R times ml used for pack titration. Don't use 1 ml here. This is just going to confuse you. Use R value times ml. This was ml used for what? For pack titration. This is the R value when you are determining the phase acid ratio. So you rearrange the equation in such a way that 25 ml here, all right, 25 ml, 0, 0, which was over titrated, minus the R value, this is the average, minus now the one you over pack titrate, you are sample number 1, you pack titrate, sample number 2, you pack titrate, sample number 3, and sample number 4. So if once you get the ml of NaOH consumed by what? By KHP, you change that to liters and plug it to this equation to get the molarity of NaOH. This is the same as this equation here, but I like just simplifying it by changing to what? Changing that ml to liters and plug it in the equation. And this number of moles of, this is the same as the number of moles of, this is the same as moles of KHP for each round. For each round. So this is KH what? KHB. So you'll have to, once you know the volume consumed by KHP, all you have to know is just the mole ratio between NaOH and KHP is 1 to 1. And there you have the molarity of your NaOH, which you now use to titrate the unknown. You don't need to do, if you read the direction, you don't need to do the pack titration for all the samples for unknown. It's recommended you only do what? You only do once, all right? You only do once. So if I were to do that, you'll have to you have to do for each trial. And remember this equation, it is for each trial, not a combined mass. I want you to take note of here. This is talking about for each what? Each trial. There is trial 1, trial 2, trial 3. So you have to titrate each one of them. You over titrate. If it is phenolphthalein, pink, you bring it back to colorless. How many ml of HCl did you use? And then you use this equation. And from there, you should have the molarity of NaOH, molarity of NaOH. That is it. From there, the rest is just for unknown. You have just to use the standardized NaOH to titrate the unknown, all right? By finding the mass, and then you just plug it in the equation. I hope that that clears the standardization of NaOH. If you have any question, we will meet on Thursday in the lab and I'll go in details one-on-one before you submit your lab report via Canvas. Other than that, thank you.